All right.
Okay.
All right. Well, I'll just go right into the slideshow here. Um, First of all, thank you very much for this opportunity to to give my first presentation in the middle of the new normal. Um, this is get used to it. So all the headlines you've been hearing about how long will it be before we get back to normal, we are normal now. This can only get worse, I'm afraid. And I'm not going to talk about all of the, or many of the different aspects of climate change that affect us. I'm just going to talk about one small piece of the pie, the emerging disease crisis. I'm hoping that my two authors on the book, Eric Hoberg, who's currently in Madison, Wisconsin, and Walter Bieger, who's in Curitiba, Brazil, will come on. And if they come on, then we'll have somebody who can answer the difficult questions for me. Now, the black elephant concept is something that Peter Ho from Singapore developed. Now, I first heard this concept at a conference in Singapore in December of 2017, and it's a combination of the elephant in the room metaphor and the black swan metaphor. So the elephant in the room metaphor is something that we know is real and we know we should do something about it, but we don't want to do anything about it, so we ignore it. And the black swan concept is the notion of a rare event that we could not have anticipated. So a black elephant is something that we should have anticipated and we didn't, and now we don't want to talk about it. And that sort of summarizes the global socio-political attitude or landscape with respect to climate change. And yet, global climate change actually is an amazing unifying force for humanity. Global climate change actually unites humanity as never before. And the reason for that is because global climate change is literally beyond belief. It does not matter what you believe in terms of social mores, cultural, economic background, political background, religious systems, ethnic origins, or anything. Climate change is going to affect you. And climate change is going to affect everybody in a sort of brutally even-handed way. So whether we want to be united or not, we actually are. And I'm going to talk about one aspect of that, which is the emerging infectious disease crisis. Now, when I talk about emerging infectious diseases, I'm not talking about rare or occasional unpleasant viruses from the tropics that infect human beings. What I'm talking about is an entire world of diseases that affect human beings and all the species that we depend on for survival and socioeconomic development. So I'm also talking about crop diseases and livestock diseases and diseases of wild fish that we use to eat and things like that. And these include diseases that we've never seen before, as well as diseases that we thought we had either contained or eradicated that are coming back again. Now, most people know that emerging diseases are a problem of some sort, but they may not know exactly how expensive a problem that is. Before, and I'm not including in these numbers, this does not include the COVID-19 outbreak that's plaguing the planet right now. But in the previous year, treatment and production costs, treatment costs and production losses from emerging diseases conservatively cost the world more than the GDP of all but 14 countries on this planet. It's an enormous amount of money. It's an enormous amount of hidden costs that we don't talk about very much. And that alone is reason to be worried about whether or not we're doing the right thing or whether or not we're doing everything we could be doing. Now, the current approach that is taken by health professionals, whether public health and medical people or veterinary, crop, livestock people, is what we call the do no harm concept. And that is basically is wait until there's an outbreak, then rush to deal with it, pretend there was no way to anticipate it. This is how the black elephant concept comes into this, and hope it will never happen again. And these are the kinds of images that are given to the public to make everybody think that we're doing something very sciencey, very sophisticated, and that we're actually doing the best we could do. But the fact of the matter is, these people are carrying out a dead body. And clearly, even though it looks very dramatic and very heroic, it's not working. And it's not working to the tune of more than $1 trillion a year before a major outbreak like the current coronavirus outbreak. Now, I'm going to talk now briefly about 3 things that most people do not know that are important. Okay, now one of those is this Stockholm paradigm that we talk about, and that is that emerging diseases are not the result of the evolution of new genetic capabilities. They are expressions of pre-existing genetic capabilities given new opportunities. In other words, all pathogens have the ability to infect more hosts than we realize, but they are not normally given the opportunity to infect other hosts. But the fact that they have this capacity to move into new hosts given the opportunity, this is actually what allows diseases to emerge very rapidly in a lot of unexpected places. Now, climate change adds to this issue because climate change, more than anything else, climate change leads to movement. Species move around, human beings move around, climatic conditions change, and it's the movements of humans and their crops and livestock, catalyzed by climate change, that exposes us to pathogens which we've never seen before, but which we're susceptible to. And because we've never seen them before, our crops or our livestock, there's been no possibility for resistance to evolve. So not only are we being affected by climate change that changes the context of exposure to disease, but it changes it in a way that increases the chances that we're going to be hit by, or we're going to be exposed to diseases that we have no resistance for. And this creates what the metaphor that we use of the world as an evolutionary minefield, or a minefield of evolutionary accidents waiting to happen. And they're not concentrated in one place. They occur everywhere in the world. And it doesn't matter where you are, it doesn't matter who you are, there is a potential emerging disease in your backyard. Often emerging diseases in your backyard. The second thing that we should know about is that cities are a problem and not a solution. And this sounds very, very strange to most people, especially because more than half of human beings now live in cities. But let me just briefly remind you that our history, the history of humanity, at least the Holocene, the last 15,000 years or so, our history of coping with climate change and disease has been the following. If a disease breaks out where you live, try to cope with it. If you can't cope with it, run away. And if you can't run away, then you die. And that's a very brutal, short synopsis of human history with respect to climate change and disease. But that's really what we have done in the last 15,000 years. Now, the problem is that as we developed agriculture, as we developed sedentary living, as we domesticated it, as we then developed urbanized, specialized urbanized living conditions, all of those things conspired to take away our evolutionary escape route. The more sedentary, the more urbanized, the more linked to a particular place we became, the less likely we were able to run away when there was a problem. So we've had, prior to the last 250 years, the Anthropocene, we've had a number of cases in which highly technologically advanced urbanized civilizations have experienced climate change events. And every time the civilization has been destroyed forever. And that's because cities limit our ability to run away from danger. So this, for example, is a sunrise shot at Angkor Wat, part of the Greater Angkor complex in Cambodia. A good friend of Hillary's and mine, Roland Fletcher, is the archaeological director of the large international program there, trying to understand what happened. And his group is the one that realized that, in fact, this large technologically advanced civilization was done in by a fairly mild but persistent series of episodes of alternating monsoons and droughts. Anthropocene cities, so that is the major cities that we live in today, with respect to emerging diseases, they are traps for us. We are much more at risk within cities than we think. They're what we call density and connectivity traps. So one of the things about the cities that we live in, if you want to know what a 3 degrees Celsius warmer planet is going to feel like, all you have to do is to visit a modern large city today, because they are typically 2 to 3 degrees Celsius warmer than their surroundings. Now, with respect to diseases, that makes them petri dishes. That makes them incubators for disease. Large cities require a constant flow of energy and water and material goods in and out. And the more flows you have in and out, the more chances you have for pathogens to be introduced. They have high population densities with low kinship, which means there are many, many people crowded together that don't know each other. And because they don't know each other, they don't know who to trust. They don't know who to cooperate with. That lessens their ability to cope cooperatively with a crisis. Now, it's not completely true. There are some amazing things that are beginning to happen. The Canadians have already named this caremongering, which I really like. Cities have extreme division of labor and extreme interdependency. Now, what that means is that they are very specialized. They can do an enormous amount of things, but typically there's a very small number of people who are able to do any one of them. So that means that if you have even a fairly small proportion of your workforce out sick, a number of functions in the city don't work, like ATMs and your cable and things like that. Large cities are safe environments for zoonotic diseases. And the more urban green spaces we create, the more space for zoonotic diseases and their vectors we produce. Now, I'm not saying that we should get rid of urban green spaces, but what I'm saying is that we have to understand that one of the prices for having urban green spaces is that a lot of urbanized animals that are reservoirs for diseases that can infect human beings love urban green spaces. And then most importantly, the lifestyle of people who live in cities, the middle class and above people that live in cities, their lifestyle is supported by an underclass of people who are largely invisible to public services. They're poorly educated, they are poorly nourished, they are poorly served by public services, and yet those are the people that clean our toilets, collect our garbage, wash our clothes, clean our dishes, prepare our food in restaurants. They do all the jobs for low wages that actually can potentially put us in harm's way with respect to diseases, and they're the ones that are most invisible to the public service sector. And these are also the people, because they're so poorly paid, these are the people who cannot afford to stay home if they're sick. So they're going to show up for work even if they're sick. And those are the people who, for no fault of their own, these are the people who are going to be most vulnerable in cities. Now, this is important because in 1918, during the Spanish influenza pandemic, 14% of human beings lived in cities. In 1950, 30% of human beings lived in cities. More than 50% live in cities now, and by 2050, almost 3/4 of all human beings will live in cities. So this is a major problem. This is part of the new normal. Number three, after giving you two pieces of really bad news, now I'm going to give you a little bit of good news. And that is, we have no sense in general that we can actually be proactive about emerging diseases, that we can actually do something. You're conditioned by the press to believe that we could never have anticipated any of these things. There's nothing we can do. Everybody's doing the best possible science. But in fact, it's not true. There's a lot more we could be doing, and we're not doing it. And we should be doing it because we're out of time. We don't have any more time. It's not that the time is short. It's simply that there is no more time. And one of the things that's very interesting is that in the 1950s and 1960s, part of the science, the golden age of science fiction, was a large series of apocalyptic and post-apocalyptic novels about the collapse of society. And so you had statements like this from Isaac Asimov's Foundation in 1951, the year that I was born. It turned out that we didn't have much time after all. And even though we didn't have much time, we wasted it. And so what do we do now? And that's the situation that a lot of countries are in right now. Oh, what do we do? So it turns out that with respect to emerging diseases, in addition to the crisis response that's overwhelming our healthcare systems now, there are some things we can do. And the strategic metaphor for this is what we call anticipate to mitigate. Instead of hoping that it will never happen again, understand that it will happen again and again and again, and each next time may be worse than this one. We have to get ourselves into a mindset of understanding that as terrible as COVID-19 is, it's pretty mild compared to what's out there that could potentially break out. We need to know what's coming at us. We need to anticipate where it's going to go, what it's going to do, when it's going to get there, so that we can buy time to try to come up with effective solutions to cope with these things. And the tactical metaphor for that is the action plan for this, is what we call finding them before they find us, or the DAMA protocol. And DAMA is an acronym for document, assess, monitor.
Dynamic, right? So that's one of the words.
So it turns out we'll get to you guys later. It turns out that a lot of these activities, the documenting and assessing and monitoring activities, are actually not that expensive. They can integrate with people who are using a lot of expensive, sophisticated equipment and materials. But a lot of things that can be done by citizen scientists working in concert with specialists. A lot of this involves what we call sweat equity, which is human beings getting out and looking around. Grandparents showing the grandkids where they might find something interesting, and the grandkids taking a photograph on their cell phone and uploading it to a surveillance app for disease control, and working in that way with specialists remotely to actually find problems before they find us. So the fundamental DAMA services for humanity that we envision is that they will tell us disease-causing organisms that are already present but not yet causing a disease outbreak. This is really, really critical. Most pathogens are among us before they cause a disease outbreak. That's one of the reasons you see an explosion of cases, because we don't know it's there, we don't know where it is, and then suddenly, boom, it's all over the place. Once we know where it is and once we know what it is, we can know how to reduce exposure to it. We can teach people what the early warning signs are. We can talk to people about what may not be here now, but what is likely to be coming, what's likely to be here in the near future. Make it more difficult for those pathogens to become established in the new areas, and know the warning signs of early establishment of those things. So this is all about buying time. This is all about getting ahead of the curve. And it allows researchers like me to do what we call focusing our research beam. We know that we need to look at what are called the interfaces between different kinds of habitats. So the interfaces between the forest and agricultural land, between agricultural lands and the suburbs, between suburbs and the heavily urbanized areas. Because one of the things we know is that in those interfaces, that's where what we call the reservoir hosts live. So if you have, for example, in Hungary, if you have domestic hogs, domestic pigs that are infected with African swine fever, you know that in the forest adjacent to your farm are wild boar that are also carrying that virus. And if you just simply treat your domestic hogs for the virus, you're not going to eliminate it because the reservoir hosts in the forest will always be there. And so long as there's an effective interface there between the wildlands and the domestic, the wild boar and the domestic hogs, the disease will continue to circulate and continue to be a problem and continue to be an economic burden on the producers and the people who ultimately have to pay for the food. As I said before, the DAMA protocol is extremely well suited for tapping into the energy and the enthusiasm and the creativity and the anger of younger people. This particular photograph is not a group of people who are working on emerging diseases. This is a group of undergraduate students in the lower Ninth Ward of New Orleans, 6 months after Hurricane Katrina destroyed that part of the city of New Orleans. These are a bunch of American undergraduates from Bowling Green University in Ohio who decided that it was more important to come to New Orleans and help people rebuild than to stay in classes. And so they took an entire semester off and came down just to help people rebuild. And this is an enormous amount of potential that we're missing. And this is what's being called now, let the young people drive. I mean, the reality is that my generation has some experiences to pass on, but it's the generation of people this age in this photograph that are going to have to solve the problem because it's their children, my grandchildren, great-grandchildren, who are going to have to live in the shitstorm if we don't do something about this. Buying time is the watchword. Our job right now is to try to save as much as we can. Anybody who talks about reversing climate change, stopping climate change, saving everything, going back to the way it was, is delusional. The reality is that we have wasted so much time and we have gotten to such a severely critical point that everything we do from now on has to be thought of as a kind of triage, where we can't save everything, we can't do everything. We have to save as much as we can. We have to be as effective as we can. But we're not going to be able to do everything. And the more we cooperate, the more we help each other out, the more we'll be able to save. But we are in very desperate times, and we need to internalize that. Now, this is the point where I plug our book, and this is the copy of the book, University of Chicago Press, blah, 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 blah. There's a lot of information in this book. Chapter 9 is an entire chapter about the DAMA protocol. And there are additional studies that we're doing, additional things that are coming out along this line. There's a brilliant group of young researchers at the National Institute for Ecology and associated universities and institutions in Budapest, Hungary, that are working on a Stockholm Paradigm program, a DAMA program for the entire country of Hungary. If in fact that's successful, if they're able to get the funding for that, Hungary would be the first country in the world to actually commit to being proactive about emerging diseases. And my suspicion is that as soon as somebody starts one of these, other places will start to copy it and pick it up. So that's pretty much all I've got to say. At this point, I'm more than happy to answer some questions. I know some of you are going to want to ask particular questions about COVID-19, and I will answer what I know. But if your questions are mostly about what do we do now to deal with the crisis as it's unfolding, all I can say is that at this point, in terms of crisis response, we're doing everything we can. And the fact that that's not very good is an indication of how unprepared the world's health organizations, from the World Health Organization all the way down to local clinics, how unprepared we are for dealing with this kind of thing that's going to become more and more common in the years moving forward. But what I would say from our perspective, the one thing that we need to be thinking about right now that no one's talking about because everyone's preoccupied with social distancing and self-quarantining and all these sorts of things, the thing that we should be thinking about is knowing that this particular coronavirus probably originated in bats, lives in bats, was some recombinant, rare recombinant genetic variant, was able to get into a different kind of mammal where additional variants were able to thrive, some of which were then able to infect human beings. The fact that we know this is what we call in the book, we call this the stepping stone dynamic for changing hosts. But that can go in two directions. So knowing that all the human beings on this planet that are infected with COVID-19 right now are part of a dynamic that went from bats to some other mammals to humans means that every one of those people can potentially infect some other mammal and back into bats in their home countries. So the big problem we have to worry about now, and the US military has addressed this when they had a press conference and said 2 weeks ago, we expect this virus to reappear next winter. And the reason for that, the reason for saying that is because they anticipate that it's going to become established permanently in the United States. And we're not doing anything to try to anticipate that. We know it's going to happen. We could be out there looking at potential new reservoir hosts, but we're not doing it. So that's, from our perspective, that's what we should be doing. In addition to all the measures that are being taken now, the rapid effective tests, the vaccines, the medications, the palliative care, the social distancing, all those things that need to be done to try to quiet this epidemic down now, that's essential to do. But the reality is we have to be prepared to try to make sure this doesn't happen again. And so far as I can tell, we're not doing that. We're not even talking about that yet. Okay, so I think that's pretty much where I am. And I will flip over now if I can. There we go. Oh, look at that. I'm almost technological here. If we've got some questions, let's see. So somebody says here, is the DAMA protocol not simply a Band-Aid for our new normal? That's an interesting point. It is, of course, that's of course what we do not want. I mean, we want the DAMA protocol to lead to effective proactive measures. And the critical issue here is that last part of DAMA, the act. And scientists are really good at documenting, monitoring, assessing, and then going to policymakers and politicians and saying, here's what we've discovered, here's what we found out, here's the threat, now do something. And the biggest problem that we have at this point is that we have actually been ineffective in convincing policymakers and politicians to invest in truly proactive measures. Let's see, what else have we got here? Ooh, this is interesting. How would you predict the stepping stone dynamics? my good friend and colleague, Walter Bieger in Curitiba, Brazil, is the head of a really brilliant mathematical modeling group that also is run by Sabrina Araujo, who's also a brilliant modeler. And they're the ones who actually have done, Walter was the one who saw this stepping stone dynamic in the real world and brought it into the modeling environment with Sabrina and her group. And they've actually done some modeling to give us some idea about the potential for that. It's our ability to predict stepping stone dynamics is improving. And one of the sad things about the situation, the original situation in Wuhan in China, is that there were Chinese virologists in Wuhan studying this particular group of viruses because they were concerned about this exact problem, this exact potential. So let me give you a side bit. Let me give you a story that's feasible and reasonable, but not necessarily all completely documented. So let's assume that China has an outbreak of African swine fever that wipes out a large part of its pork production. That's true. And let's suppose that when Chinese pork production drops, that drives up the demand for exotic forms of meat because people can't get their domestic forms of meat. That drives up the demand for what we would call bushmeat, for exotic game animals. Now suppose you have a situation in which there is such a large demand that large open-air markets selling all kinds of different species of mammals spring up. And in those places, you have not a lot of inspection, not a lot of public health control, not a lot of livestock inspection control. You have lots and lots of different species, carcasses together. You easily could have cross-contamination, and that's the way you can get these kinds of stepping stone dynamics to occur. So one young virologist that I spoke to said that when he looked at the market in Wuhan, where this seems to have really exploded at first, he looked at it and he said, this is a SARS factory. This is a place where SARS-like coronaviruses are most capable of engaging in this kind of stepping stone behavior. So we're learning, unfortunately, we're learning the lesson late, but we're trying to catch up as fast as we can. And so the short answer is that I think we'll be better next year than we are this year. Unfortunately, we were not as good this year as we had hoped to be. Somebody else has asked about machine learning and genomics. Well, yes, of course, these are two categories of really important tools for trying to speed up the process. So what we need to do with trying to document what's out there, we need ways to speed up the identification process and to speed up the assessment of what this means. So one of the things we talk about is when we find we go out in the environment, we check, we find a whole bunch of viruses or a whole bunch of bacteria, and we don't know which ones to focus on. What we can do is what we call phylogenetic triage. That is, we examine everything that we found in the context of their phylogenetic or their evolutionary relationships. And if what we find matches something that is a known pathogen, then we take that aside for special assessment and special observation. If it's a close relative of something that's known to be a pathogen, we also put that in the high risk group. If it's not known to be a pathogen and if it's not related to a pathogen, we set it aside and we don't pay any attention to it for the time being. We move on to the ones that are the critical problems right now. And that's where things like machine learning and genomics can play a heavy role. Let me see. Okay. The only recommendation you have for the general public is to participate in citizen scientist initiatives. Well, um, I, hmm, there is a lot more to it than that, but this is a 40-minute presentation of a general topic that most of you have. So what I would say is that there is a lot more to that. There are, I have, and Eric and Walter and the rest of us have entire talks that we give just on setting up the relationship between citizen scientists and specialists and what the actual activities would be. The proposal that we've submitted to the Hungarian government is 20 pages of infrastructure, all the way from the boots on the ground to satellite surveillance and integrating everything along the way. So it's all I can say is that it's more than just recommending that the general public get involved. What we're saying is, in fact, that this is more than just a plea by scientists for more money for their scientific projects. This is a public policy project. It's not a science project. Investigations on long-term side effects of emerging diseases. And what's the economic effect? Well, that $1.3 trillion that I spoke about, you can double that for this year just with respect to COVID-19. We can assume that there will be a global recession this year. We will assume that people are going to be hurt. So in this small town in North Carolina where I live, all the schools are closed. Okay? So that means that the kids are learning online. And there's some wonderful things. The major local internet provider is actually giving kids whose families cannot afford home internet connection, they're giving the kids 2 months of free internet access so they can do their studies for the rest of the semester. And this is a good thing. But the reality is that every one of those families where the kids are now staying home, one of the parents has to take off from work and stay home with them. Restaurants are closed, theaters are closed, bars are closed, Starbucks is closed, gyms are closed, fitness centers are closed. And those are full of people who are going to be hurt economically. And we just simply cannot minimize the kind of economic damage that can happen in a highly globalized, hyper-connected society when we allow ourselves to be blindsided by something that we should have known about and we should have prepared for. Oh, Hillary, yes. How can urban ecologists become engaged and invested in the protocol? Are there guidelines? Yes, and that's actually the person who would be best able to talk about this is one of my young Hungarian colleagues, Gabor Fuldvari, who has done this amazing study on Margaret Island, a major tourist site in Budapest, in the middle of the Danube River, between Buda and Pest. And he was one of the first people basically just to take a group of parasitology students out to the island to look at the ticks in the hedgehogs and then to look at what pathogens those ticks might be carrying around. And he discovered an enormous potential health risk in pathogens that the ticks were carrying that had not actually broken out yet. I mean, in a sense, we had been living on borrowed time. Gabor was able to identify the potential risk before anything happened, talk to the city government about this, and because we know a lot about how these tick-borne diseases are transmitted, it turned out, the short answer is, it turned out that simply by putting a lot more public toilets on the island, we were able to minimize the possibility that anybody would be infected by those tick-borne diseases that are on the island. So again, we do have some ideas about what to do, and we're working as hard as we can to try to convince people to enact more and more of these kinds of activities. Urban ecologists need to, well, anybody who talks about what are called ecosystem services has to understand that the ecosystems that provide the most services in terms of carbon sequestering and oxygen release and other kinds of positive things, those are also the ecosystems that are most friendly to pathogens and their reservoirs and their vectors. And we simply have to take that and keep that in mind, and we have to factor that into what we do. So if you're going to expand the number of urban green spaces in your city, you also have to have a program of monitoring things like rodents whose populations will increase because they now have more nice habitat to live in. Somebody says, and I'm not answering all these, I'm sort of flipping through. So if I pass you by, I'm not, it's not intentional. You said cities are not the answer, but that's very contrary to common belief as well as the United Nations Sustainable Development Goal. This is true. They're wrong. And fortunately, you have one of the world's authorities teaching this course, Hillary Brown, to talk you through that. And the second part of that question was, is there any momentum with encouraging city dwellers to migrate away? Well, the answer to that is that we are in a situation now where scientists can anticipate that within the next 30 to 50 years, if we don't move our large cities away from the seacoasts, people are going to have to move anyway. And it's a question of relocating our population voluntarily or relocating our population in a panic into areas that are not prepared to receive them. There's some very, very interesting things. Hillary has some really interesting ideas about that. And it involves issues of circular economies. And it also is connected into the notion of this general replacing the economics of linear production and profit with the economics of well-being. So part of the answer is there are ways to redistribute the population. There are ways to reduce the population density without losing the essential services that make cities so interesting. And they don't necessarily, they do not involve the notion of abandoning all the large cities that are on the seacoast. The idea is to anticipate what could be happening, prepare for it. It's, there's this saying that prepare for the worst and hope for the best. And there are a lot of ideas out there, but you're also correct that this goes against the fundamentally traditionalist, economically driven, primarily neoliberal agenda that says more, bigger, bigger, faster, faster, that we know is not working. And our response to that is, well, if it's not working, we'll just keep doing more and more of the same thing. So if big cities aren't working, then mega cities will solve the problem. If mega cities don't work, then mega cities will work. This is not the answer. It's never been the answer. And it's not going to be the answer this time. Let's see. Oh, why is the coronavirus so dangerous, and why does the flu not get this much attention? Okay, a couple of reasons. All right, first of all, I'm going to give you a cynical old guy, child of the 60s, anti-Vietnam, pro-civil rights marcher perspective, and that is that this particular virus is targeting the age group of the people who are in power. So if this was a virus that was targeting people who were 30 years old or 15 years old, the attention of the people in power would not necessarily be as well focused as it is. But in addition to that, what is interesting about this virus is that it is much less harmful than some of the common influenza variants, but it's much more infective. In other words, you're going to have far more people infected with COVID-19 than with influenza. So that even though a smaller percentage of the ones infected with COVID-19 will die, you could end up with far more actual people dying than die from the influenza outbreaks every year. One of the other problems we have, of course, is that because human beings have not been exposed to this particular virus before, there is a much smaller proportion of the human population that is resistant to being infected. As we go along, this will increase. The number of resistant human beings will increase around the planet, and this will help mitigate subsequent outbreaks. This will outbreak again, this will break out again and again and again. But as we have a larger and larger proportion of human beings who are resistant, the actual health impact and the economic impact will be less. On the other hand, you also have to understand that one of the issues is what we call comorbidity issues. That is, people who are dying from infection with this virus tend to be older, although there are now troubling reports, especially in Italy and the United States, of young people becoming infected and badly ill. Up until this time, we've been saying, oh yeah, young people get infected, but they don't get very sick. Now we're starting to see young people who are very ill with this. What we don't know about, we don't have enough information about the people who are extremely ill, except for very old people, where we know that they oftentimes had other pre-existing medical conditions that already weakened them. We don't know if some of the younger people in their 50s, their 40s, and so on, we don't know if some of those are people who also had, say, cardiovascular disease problems that they may not even have known about before they became sick. So again, because we're responding in crisis mode, we're learning this on the fly instead of having an idea about the possible potential of this thing before it got out. Okay. How come we aren't talking about people to animals proximity? That's exactly what I was talking about when I talked about interfaces. That's exactly the reservoirs. The reservoirs, by definition, zoonotic diseases are diseases that have reservoirs in non-humans. And every pathogen in a human being that causes a disease, you can bet that there's one non-human animal somewhere in the wildlands that's infected with that pathogen and is not sick. And we don't look for those things. We don't look for pathogens in people who are not sick. We don't look for pathogens in cattle who are not sick. And we certainly don't go into the wildlands and look for potential reservoirs to the extent that we should. We know a little bit about it, but it's not done on a systematic basis. And we can do that, and we should be doing that. There's a question here about why the United States was so slow to respond. I think the answer to that is obvious. The current central government of the United States is non-functional. It is dysfunctional at best. With respect to this, it is non-functional. In addition to the general background of the entire public health world being slow to respond to anything because they're not proactive, they're not trained to be proactive. But on top of that, you have a number of issues. In the United States, you had initial denial that this was even happening. The scientific community and the public health community had to fight with the central government to try to get anything done. We even had a situation where the head of the National Institute of Health
tonight.
contradict the president of the United States in a press conference when he said something stupid, but also irresponsible. So the issue with the United States is that there are some political infrastructural problems that are keeping the United States from responding adequately to any of these challenges posed by climate change, diseases, or anything else. Let's see. It came from bats. What other animals were we capable of getting the diseases from? Well, first of all, remember, we did not get this thing directly from bats. We got it through this stepping stone mechanism, which is really, it's very cool biology, but it's really, really tricky, and it's really problematical, and something we need to spend more time thinking about. But almost all of the disease-causing pathogens that human beings have, the vast majority of them originated in non-humans. There are diseases that we have that we acquired from animals that we used to hunt and eat. There are diseases that we have that we've acquired from animals that we domesticated. There are diseases that we have from animals that we now share urban living conditions with. So a lot of rodent-borne diseases, a lot of rat-borne diseases like plague and Hanta and things like that are diseases that human beings only came into contact with when they established habitats that rodents like to live in. And those are cities and towns and places where we store lots of grain and things like that. Should we expect pandemics to occur more often? It's a two-part answer. First, the short answer is yes. The second answer is they're already happening much more rapidly than you might think. They don't make the headlines, let's say that, okay? But there are a lot of things happening that may not cause a large-scale outbreak. They may be a very intense problem in a small part of the world. They may be a general background problem in a large part of the world, and they're just simply not getting the publicity that they should. Most people, for example, don't know that we anticipate that African swine fever outbreaks throughout the world are going to decrease pork production in the world by 25% this year. Most people don't realize that there's a rust fungus attacking wheat in the Near East and now in the Mediterranean of Europe that does not respond to any known fungicide, and none of Monsanto's genetically modified variants of wheat are resistant to this fungus. And so there are people who are actually talking about the potential impacts of the extinction of wheat within 25 years. That's 25% of the calories that human beings take in every day across this planet. So if we lose wheat, we lose 25% of the calories that human beings rely on every day. And nobody is really talking about these things very much. So a lot of this is already happening on a different level. One of our primary petri dishes for emerging diseases are things called cruise ships. Now, before we started hearing about cruise ships being infected with COVID-19, before that, for the last 10 years, there have been increasing numbers of cruise ships that have been affected by what are called norovirus outbreaks. These are outbreaks of a relatively mild but unpleasant diarrhea syndrome that also hits public schools at times. But this has become very, very common on cruise ships. Initially, people said, oh, it's not going to be a big deal because the virus only lasts for a few hours on surfaces. So all we have to do is disinfect everything and it'll be fine. Now we know that noroviruses can actually persist in places like cruise ships for up to 6 months. And we just, by not taking these things seriously, we're not doing what we ought to be doing to take the proper precautions. Isn't it a dangerous trend to consider this mostly a senior citizen problem? Yes, of course. And your analogy with HIV is absolutely right. Initially, in the United States, for example, the central government didn't care about HIV because they had decided that this was a gay disease, and they didn't care if a lot of gay people died. And considering COVID-19 to be primarily a disease of older people, that misinformation is the reason why there are so many university students all crowded together along the Gulf Coast and the Florida coast right now on spring break. They have decided that, oh yes, well, I may get infected, but I'm not going to get sick because I'm young, and there are no old people here, so they're not going to get sick. And they don't understand that they're going to be infected, they're going to be carriers, they're going to go home after spring break, and they're going to kill their parents and grandparents. And this is not a good thing. As well, as I said before, there are now reports that are showing up just in the last couple of days of younger people becoming very ill with this. We don't know exactly what that's like, what that's all about, but this is something. The questioner's point is absolutely right. Do not consider this just because most of the people who are dying now are old people who are already sick. Don't think that that's the whole issue or that that's the end of the problem. Poor policy, poor cooperation, poor planning. Yeah, I mean, this is all sounds common, and that's true. The reason we're having these kinds of problems with diseases is also the reason we have problems with good quality drinking water. It's the reason we have problems with bad sewage. It's the reason we have problems with soil depletion. It's the reason we have problems with sea level rises and poor construction along coastlines. It's all part of the same general thing. Now, the good thing about that is if we figure it out, if we figure out how to cooperate and make some good things happen proactively in one area, then we ought to be able to apply those lessons to other areas. But one of the cautionary things that I say in some of my talks, and Hillary's heard me say this, is that one of the biggest problems with coping proactively with potential emerging diseases is that you have to cooperate with your neighbors to share information, even if you don't like those people very much. And human beings do not have a good history of cooperating with people they don't like. But because these diseases don't really care whether you like each other or not, we're put into a position where we have to be able to try to set aside our differences at least well enough to help each other out because it's to our mutual benefit. What's necessary to scale the solutions for circular economy? Well, I did talk to Hillary. That's everything I know is what she has taught me in the last 4 years and the literature she's put me into. And I know enough now to know that I'm pretty ignorant about the whole area, but I'm really fascinated by what we could do. And there are ways, of course, in some of these ideas for circular economies and centers for innovation within small cities of circular economies. Part of what you could do in those innovation centers is to have a place where you have people to talk to local people about potential disease problems in their gardens and farms, in their livestock, in the kids. Teach people to, when they go out in the forest in the summer, teach people to look for ticks on their children. People don't do that as much as they ought to. What do you do to minimize the possibility of mosquitoes coming into your garden, things like that? So there are lots of cooperative things that can be done. But if you want to speak in terms of the general framework of circular economies, Hillary's the one right there, and other people that she knows, of course, who would be best able to talk about that. We're going to see an increase in novel viruses, yes, and novel bacteria, and novel protists, things like malarias and relatives of malarias, novel worm parasites. A lot of people think that viruses, because they get all the publicity of all the major groups of pathogens, viruses, bacteria, fungi, protists like malaria and their relatives, and worms like tapeworms and roundworms and things like that. The group of pathogens that has the greatest economic impact every year are things like tapeworms and roundworms. The things that have the least economic impact on a year-to-year basis are actually viruses. Bacteria cost us more every year. Fungi cost us more every year. than viruses. But viruses have the possibility of blowing up very quickly into something that can create headlines. There's something here about systems. Oh, yeah. Can you speak about a systems thinking approach to this problem? Well, that's our entire approach in the book is a complex systems approach to this. And generally that means that, and one of my really good friends, Alicia Huarero, is a philosopher of science who wrote in 1999, she wrote what is kind of the Bible of complex systems thinking in the ecological context. And so I always paraphrase her dictum by saying, it's never just one thing and it always depends. And that's sort of the complex systems issue in a nutshell. It's never just one thing. It's never possible to say this caused that. It's always a string of events. And most of the time, the string of events can be unconnected. There's no great conspiracy. There's no great plan. It's just people doing disconnected things, not paying attention to potential consequences, and suddenly you have a concatenation of phenomena that blows up in your face. One person here wrote, we can't kill rodents, but we cannot eat bats, pigs, and cows, and so on. Yes, that's true. But the interesting thing about things like rodent control is that you can make the habitat where human beings live less attractive to rodents. You don't have to kill them all. You just encourage them to live someplace else. And the same thing is true with animals that, this idea that don't eat this animal, don't eat that animal. Many of the animals that are potentially capable of transmitting diseases to us will make us sick if we do not prepare them properly. It's not a question of if you eat a pig, you will get sick. It's if you eat improperly prepared pork that you will get sick. If you eat improperly prepared beef, you will get sick. So part of the story here is not necessarily to not eat these kinds of animals, but to make sure that they're properly processed for eating, and that people know that they need to cook the meat well and that sort of thing. But remember also that we have three major kinds of avenues for transmitting four major avenues for transmitting disease. One is direct contact. So people sneezing on somebody else, people sneezing on a surface, and then somebody puts their hand on the surface and then brushes their nose. That kind of direct contact transmission. We have transmission in food. So poorly prepared pork, poorly prepared beef, for example, poorly prepared game meat or bush meat. That's another way that diseases can be transmitted to us. We have diseases that are transmitted in water. Cholera, for example, is transmitted in water that's contaminated with sewage. We have vector transmitted diseases. So things like malaria and yellow fever are transmitted by mosquitoes. We have things like dengue and like Zika, which is a virus, but Zika is transmitted by mosquitoes some of the time, but it's primarily a sexually transmitted disease. And we have decided that it's a disease of women, pregnant women. So we've decided that women get pregnant, then they get infected with Zika, and then their baby is born with developmental problems. The reality is that in most cases, when you have a Zika baby, either the mother or the father was infected at conception, and the virus was incorporated into the embryo from the beginning, and that's why you have so many developmental problems. And we're not looking for that. If we decided that we should only be testing pregnant women for Zika, it's too late. And we're not, in the case of Zika, we're not testing men at all. And an analogous thing would be if we decided that we wouldn't test people for HIV unless they said they were gay. we wouldn't test people for COVID-19 unless they were 80 years old and already about to die. So we can't afford to do these sort of silly things anymore. Hillary wants me to talk about crop-related things, issues, and climate change. Well, this is a. I mean, I'll tell you what I know, which is not an enormous amount, but I know more than I did 2 weeks ago because I was invited to participate in a forum on food production, sustainable food production, and sustainable agriculture in Washington, D.C. 2 weeks ago. And what I discovered was that nobody wanted to talk about disease. Everybody wanted to talk about more production, more intensive production, more production, more intensive production. And people like Tim Benton from Chatham House were saying, but this is not sustainable, economically unsustainable. The nutritional value of this mass-produced stuff is crap. Your profits are decreasing. You're killing the soil. You know this is terrible. And they said, yes, that's true. Now, getting back to the issue of increased production, and it was astonishing. Tim actually had me invited specifically to talk to them about diseases, and nobody wanted to talk about it. I mean, literally, in breakout groups, it was like, we don't want to talk about that. There were no speakers who mentioned it. It was astonishing. So the biggest problem we have is that in agriculture, the countries that are extraordinarily rich have no interest. They have even less interest in doing things about agricultural disease than the public health people do about being proactive about infectious diseases in human beings. To those people in the room, diseases in livestock and crops were just the cost of doing business. And they just assume we're going to lose some, and if it gets too bad, we will simply come up with a GMO that's resistant to that pathogen. And that's like saying we'll come up with a vaccine in 6 months or a year, but we're still waiting for an HIV vaccine and a Zika vaccine and an effective dengue vaccine and an Ebola vaccine and so on and so on and so on. So the reality is that it's not that easy to do this. It's not that easy to come up with those sorts of things. And in the area of crop diseases, this is a large, underappreciated, underfunded area of knowledge and research. There are a number of people who are extremely interested in studying these phenomena, and they have a very, very difficult time getting funding. It's very frustrating because this is an area where the socioeconomic problems associated with disease overlap with socioeconomic problems associated with food production, both of which connect with things like water quality and soil quality and climate change. And so that's another aspect of this complex systems approach to things. You can't really legitimately disentangle these things. But I'm not a specialist in crop diseases per se. So again, I'm spending a lot of time trying to listen to people who are specialists and learn as much as I can, and talk about a general framework where if we're dealing with one kind of problem, that may also help us deal with other kinds of problems. One of the things that I did here in Washington that was extremely interesting was this idea of what's called push-pull agriculture or intercropping, where what you do instead of planting the same crop in every single row in your field, you plant one row of corn or one row of wheat, and the next row is a pest-resistant or disease-resistant plant species that's not a crop. But because it's growing there, even though now you're only growing half as much corn in your field, you're only losing 10% of your corn rather than losing 60% of the corn if the entire field was planted with corn. And there are a number of ideas like that. This would be a DAMA kind of thing. This would be, you teach the people what to do and say, look, if you do this, you will not be planting as many corn plants, but you're going to harvest more corn, and you're going to be able to do it year after year after year. So there are some very exciting things like that out there, and I'm doing my best to try to learn about them as fast as possible.
So, Dan, we may be coming to the end of our time frame, and if there are any other urgent questions, I think you've gone through and highlighted some really important ones. It looks to me like you had one more slide that you wanted to show, or was this?
Oh, well, that was something I was going to talk. Yeah, I can do that. Is this enough to see?
Sure.
Or do you want me to do the whole thing, the whole screen?
I think we can see it well enough. We get the idea.
Well, this is a picture. This is a picture of Europe, and all the red dots there are World Biosphere sites. These are places in Europe that have been set up for captive breeding, primarily of rare and endangered species, mostly from Africa. And as I alluded to, and some of you may know, the world is currently experiencing an outbreak of African swine fever virus, and it's hitting Central Europe particularly hard. It hit China last year very, very hard. Now, in Central Europe, domestic pigs are infected by migrating wild boar. So the wild boar have become the reservoir host for the domestic pigs. And in Europe, of course, people hunt and eat wild boar as well as domestic pigs. This virus is not infective in human beings, but it will kill pigs. It will kill domestic pigs, and sometimes it will even break out and kill the wild boar. Now, there are two questions about this. The first is, well, there are two aspects of one question. How did it get into Europe? How did it get into China? There are two ways that this virus can be transmitted. One is it can be a tick-borne or a direct pig-to-pig transmitted virus, or it can be tick-borne, the tick feeds on one pig and then feeds on another, or it can be transmitted by infected, poorly processed pork products. Now, inspections of pork products coming into the EU are pretty rigorous. And the likelihood that African swine fever was introduced into Europe that way is a favorite story by politicians in Europe, but it's extremely unlikely. One possibility that's really troubling is that if you go to Africa, where African swine fever is endemic, it is a virus that is found in African warthogs, and it does not make them sick. And I would like to know how many of those World Biosphere sites on this map at any time in the last 20 years have had warthogs. Because one of the reasons we have a hemorrhagic fever that's called Crimea-Congo hemorrhagic fever is because that hemorrhagic fever was introduced into the Crimea, into a World Biosphere site by infected African animals that were and their ticks that were brought in for captive breeding. The first African swine fever outbreak in Europe was in 2004 in the country of Georgia, and we did nothing. We did nothing to try to mitigate the possibility. And in fact, hunters associations and conservation biologists in Europe worked together to try to make certain that there were no impediments to the free migration of wild boar all throughout Europe. That's the reason that virus is all throughout Europe now. And so this is the subtitle of the last chapter in our book is, It's Nobody's Fault, but Everybody's to Blame. So people bringing endangered animals into Europe to try to bring the populations up, to reintroduce them into the wild. This is not a bad thing, except they never thought about the possibility of introducing diseases into the country because they assumed that, oh, this is an African disease. It will never, what could go wrong? And so that's what this was all about. Now, of course, then if you connect the African swine fever outbreak in China to a desire for or a demand for exotic kinds of meat because people were hungry, then you have an indirect link into an accidental contamination that leads to the emergence of something like COVID-19. And away we go.
So Dan, yeah, thank you for that closing image. As another reminder, I think you've given us a pretty crucial view of the scope and the real dimensions of the new normal. I think we can say, at least on this webinar, we've kind of lost our innocence, the dimensions of this problem. And I for one want to extend our thanks for giving us this overview, and I think we will have recorded this. If there are other questions that may arise from this, we might forward them on to you and share them with some of our.
There's some, as I was scrolling through, there's some really interesting comments here and questions, and I was going to say that if you're able to capture those and continue this conversation on, I would encourage the people who asked the questions that I didn't address or didn't address properly to continue thinking about this and move forward yourselves, and then notify me and educate me some more.
Well, we hope that we get to hear much more about this. Maybe there could be a follow-up webinar with your two co-authors.
Oh, that would be wonderful. Yeah, because yeah, they're tremendously bright people and really good people too.
So again, I just want to extend our thanks. This has been a bracing introduction to the problem and an introduction to some of the hopeful solutions. So I guess, Catherine, do we just simply sign off, or do you want to give us any instructions?
We do just sign off indeed, and I will put the link to the recording on our program website, which is City College Sustainability.
Well, thank you very much for the opportunity, and maybe next time I'll actually be able to come to New York in person.
We'll make sure that there's an opportunity and we don't have to wait a year and a half. I mean, that was the last figure I heard about the duration. So. Anyway, well, I want to thank our audience for tuning in and asking some important and provocative.
Oh, absolutely. Yeah, thank you very much.
So we'll be in touch, and Dan, I'll sign off, and we'll be in touch with you.
Okay, take care.
Thank you, everybody. Good night.
Thanks, Dan, and thanks all for joining.
Bye-bye.